So we're going to have a little look at adding some fractions that have different denominators. So the fractions that I'm going to use is 2/4 and I'm going to add them to 2/8. Now, we know that if you have a tenth, add another tenth, add another tenth, you wouldn't have 3/30ths, but you would have 3 1/10ths. You'd have 1 1/10, 2 1/10ths, 3 1/10ths. And that is because the denominator is the same. The denominator is the same. So we're going to have a little look at 2/4 and 2/8 and see how we add them together. So I'm going to show you using my rods. So this is going to represent my whole. That represents my whole. Okay. I'm then going to get my quarters and put them into place. So I've got 4 1/4 makes that whole. Okay, and then I'm going to split those again, and I'm going to get my eighths. So I've got 1 2 3 4 5 6 7 8, and I can see in my model that 2 1/8ths is the same as 1/4. So what I'm looking to do is I'm going to add my 2/4 to 2 of these eighths. Okay, now if I know that I've got 2/8 is the same as 1/4, I can look along and see that 4 1/8 is the same as 2/4. Okay, so I can actually change this here. I'm going to pull it down. I can change that into eighths to make it easier, because then I'm working with the same denominator. So I said 1 2 3 4 1/8, should be able to see that quite clearly, is the same as 2/4, which is the same as a half, isn't it really? And then I can add my 2/8 to it, and I should have 1 2 3 4 5. I should have 6 eighths. I should have 6 eighths. So you're working in fifths and tenths. So do the same. Draw yourself out a bar, split that bar into 5 equal parts, and then split the next bar into 10 equal parts, and see if you can spot a relationship between the fifths and the tenths in the same way that I've just done with the quarters and the eighths. Okay, the next example I'm going to show you is using fifths and tenths actually, and we're going to have a little look at which is greater. I'm going to look at 3/5 or 8/10, and I can do the exact same thing. I can get myself out a hole, draw myself a hole if you want to. I'm going to use my manipulatives, and I need to see, let me have a look, let's get some fifths out. So 1 2 1/5, 3 1/5, 4 1/5, 5 1/5 makes my whole. Good. So 5/5 is the same as 1 whole, and I'm going to need my tenths. So let's see how many make my whole. I know in my head that it's going to be 10. I'm just going to prove to you that it's 10 that fit in perfectly. Lovely, lovely jubbly. So, which is greater, 3 1/5 or 8/10? Well, I know that that's 2 tenths to take away. I'm going to take those away, and 3/5. I'm going to take away 1/5. I'm going to take away 2/5, and you can really see clearly in my model that 8/10 is greater than 3/5. So if it helps to draw it out, or if you've got anything that you can use manipulatives wise, go for it. Okay, so I know that 8/10 is greater than 3 1/5. Lovely. Okay, next question. Oh, a lovely division. Right, I'm going to change it slightly. 1,441 I'm going to use, and we're dividing it by 7. So we need to be thinking in our 7 times tables. So how many whole groups of 7 can I make? I can make 0. And I'm going to exchange that 1,000 for 10 100s. So I've still got the same number, remember, it's still 1,441. Okay, I'm now looking at how many whole groups of 7 I can make in my 1400s, and I know I can make 200, so we'll just put a 2 in my hundreds column, and I've got nothing left over that goes in equally, goes in evenly. Okay, I'm then looking at how many whole groups of 7 I can make with my 4 here, and I can't make any just with that 4, so I'm going to exchange that for 41s in my ones column. I've now got how many 7s equally, evenly go into 41. I need to be in my 7s times table, and I know 5 go into 35. Can I make another 7? No, I can't, because that would be 42. So I can make, oops, sorry, I've got to put my 0 in there. Really important, nearly made that mistake, didn't I? I've got to put the 0 there because I can't make any, and then I've exchanged. Now I've got how many 7s go into 41, and I've got 5, which is 35. So I need to figure out what my remainder is by adding on from 35 until I get to 41, which I know is 6. So I would leave my remainder as 6. So it's 205, remainder 6 for that one. Lovely. Okay. See, even teachers make mistakes sometimes. Right, chocolate bars. They cost 25p. And I have 6 of them. So how much do 6 chocolate bars cost? Okay, so to help you if you want to handle this one in a pictorial method, we can draw up ourselves a bar model. We know we've got 6 of them, okay? We know we've got 6 of them. Each of them is 25p. 25p, 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 25p. Okay, so to work out your whole, you've got 6 lots of 25p. 6 times 25p. Now I know that 25 times 4 gives me 100. Okay, I know that 4 times 25p is going to give me £1. And then I know that I've got 2 25p's left, which is going to give me 50p. 2 times 25p gives me 50p. Add them together and I've got my chocolate bars, 6 of them that cost 25p. Is going to cost me £1.50. So you've just got to substitute 25p for 35p. Okay, enjoy.